Right, everybody managed to get the results? Okay. Right, so I want to get through as much theory as we can, so we'll have plenty of time to revise in class. You can ask me any questions. So carrying on from we're sort of accumulating. We've done our F equals MA revision. Guys, I'm not going to talk over you. We've done our F equals MA revision. We've also now done sort of resolving the vectors. Okay, so remember, if you've got something going at an angle, you can work out the x component and the y component of it. Okay, so this is kind of like taking all of those into account. So there are some situations where forces must be resolved into perpendicular components that are not horizontal and vertical. So all of these are things going down slopes. And to work out the unbalanced force of something going down a slope, we need to know the component of weight that goes along the slope. Okay, so if you've got something pushing this up, then you'll have a force that way, and then you'll also have a force that way, which will be a component of the weight. Okay, so that's what all these questions are about things going up and down slopes. So, may help you if you've got like a colour or something like that to draw on this diagram, because there's quite a bit to draw on it. So we've got a block of wood, mass 2 kilograms, is placed on a slope which makes an angle of 30 degrees to the horizontal. So that means that angle there is 30 degrees. First of all, part A, find the component of weight parallel to the slope. So basically what we want is this component of weight. Okay. So what do we know? So we know that it does have a weight, and the weight would be down the way. So this case, the mass is 2 kilograms, so 2 times 9.8, which is 19.6 newtons. This I'm going to label WS, for weight on the slope, or the component of weight to the slope, parallel to the slope. So we've got sort of a triangle forming here. If we join those two up, a right angle triangle. Okay, so we want to find WS. Okay, so we need the angles for that triangle. So I'm going to redraw that triangle just underneath it. So we've got WS, that's a right angle. And that's our weight, so 19.6 newtons. We need some angles in there because we can't really do anything with that unless we've got some angles. So if we look, we've got 30 degrees here. If that's 90 degrees, then what's that angle going to be? 60. That's the same angle as that. That's 60. So that's 30 as well. So we can draw those in. So that'll be 60 degrees. So that's also 60 degrees. No, not on this one. Sorry? Okay, so we've got a triangle. Okay, so we need to work out what WS is. So we can use cos. So cos of an angle is adjacent over hypotenuse. So let's use 60. So cos of 60 is the adjacent divided by the hypotenuse. So WS is 19.6 times by cos 60, which comes to 9.8 newtons. Sorry?
That is a coincidence or expected?
It's just a coincidence. B asks you to calculate the acceleration on the block down the slope with the frictional force acting on the block is 4 newtons. And that is just what you would normally do. So we've got now a 2 kilogram block. We know what this force is, it's 9.8 newtons. We've got a resistive force of friction, which is 4 newtons. So you use unbalanced forces, mass times acceleration. So they need to be on the same plane. So 9.8 take away 4 is 2 times acceleration. So acceleration comes to 2.9 meters per second squared. Yeah, just calculator, put it into calculator. Okay, so have a read through the next one. I'll load that up. So example 17 is an all-in-one question. So it hasn't been nice and split it up into part A and B for you, but you have to do the same thing again. So you have to find out the component of weight parallel to the slope, then use F equals ma. So whereas example 16 would be like a maybe 3 marker and a 3 marker A and B, this one would probably be like a 5 or a 6 marker all in one. Okay. Is anyone still sorry? Yeah. Yeah, it's very rare you get anything more than that. Is anyone still writing? Sorry, are you still writing? Okay. Right, so example 17, a box of mass 15 kilograms is placed on a slope which makes an angle of 30 degrees to the horizontal. When the box is released, it accelerates down the slope at 2.5 meters per second squared. Calculate the force of friction acting on the box. So we want to know the force of friction. I'm going to label that FR for friction. So to find that, we have to work out what our component of weight down the slope is. So draw in our triangle. It's the same triangle every time. So you've got that'll be the same as the 30 degrees, 60 degrees. And mg is 15 times 9.8, yeah. So to work out what the component of weight down the slope is, cos 60 is going to be adjacent over hypotenuse, so WS over 147. So WS will be 147 times by cos 60, so 73.5 newtons. Then you look at the whole picture again. We've got friction, we've got WS, oh, 15, yeah. So to find the force of friction, we use unbalanced forces, mass times acceleration. So in this case, it would be WS minus the force of friction is mass times acceleration. So WS is 73.5. Take away the force of friction is the mass, which is 15, times by the acceleration, which is 2.5. So friction is going to be 73.5, take away 37.5, which is 36 newtons.